Hi everyone, I hope you all are doing good. So in my today's session, I'm going to explain about one of the structural design pattern called decorator pattern. So what is a decorator pattern? The decorator design pattern allows us to dynamically add new functionalities to an existing object without altering or modifying its structure, and this design pattern acts as a wrapper to the existing class, plus it will add also additional functionalities, guys. That means decorator design pattern dynamically changes the functionality of an object at runtime without impacting the existing functionality of the object. In short, this design pattern adds additional functionalities to object by wrapping it. Okay, do understand when you use a decorator pattern, right? Your decorator pattern basically provides additional functionalities or features to an object, not to a class. This is not a subclassing, this is not inheritance. It's basically an aggregation. Class contains a component, okay, to that component it provides additional features. Okay, so that is all about the decorator pattern. Okay, so that's why I've highlighted in bold. Do remember that a decorator is an object that adds features to another object. Okay, so its adherence to two solid principles. Yes, the decorator pattern is often useful for adhering to the single responsibility principle, as it allows functionality to be divided between classes with unique areas of concern, as well as to the open close principle by allowing the functionality of a class to be extended without being modified. Okay, so you people may be thinking, okay, just now we were speaking about adding features to another object and no subclassing, but no, whatever subclasses you create, right, these subclasses are basically the decorators subclasses, which again contain your existing object, your existing component. Okay, for which you don't have any source code, it is just a DLL you have. Okay, so it's kind of some legacy component or a legacy class which whose object you basically maintain inside these decorator classes. I'm going to explain this in detail, so do understand it adheres to single responsibility principle because it allows the functionality to be divided between classes with unique areas of concerns, and open close principle by allowing the functionality of a class to be extended without being modified. That's what subclassing the decorators basically. Now, the problem solved by the decorator pattern. Responsibilities should be added to and removed from an object dynamically at runtime. See, decorator pattern not only meant for adding some responsibilities, but it also involves removing some unwanted functionality from an object at the runtime. Okay, a flexible alternative to subclassing for extending the functionality should be provided. So this is what the problem basically decorator pattern solves. Okay, it is not just a wrapper like a facade design pattern. Okay, but it basically provides the extended functionality to existing object. Okay, so decorator use can be more efficient than subclassing because an object's behavior can be enhanced without defining an entirely new object. Here, this particular statement, okay, because an object's behavior can be enhanced without defining an entirely new object, means we are speaking about the existing class or object, okay, or a DLL, which basically contain a reusable component for which we have to provide additional features, not the decorator. Okay, now architectural relevance. Decorators support a compositional rather than a top down. That's what I was speaking. Decorators support a compositional rather than a top down hierarchical approach to extending functionality. Okay, a decorator makes it possible to add or alter behavior of an interface at runtime, that's to your object. Okay, they can be used to wrap objects in a multi-layered arbitrary combination of ways. Okay, doing the same with the subclasses means implementing complex networks of multiple interfaces. See, the same thing we can achieve through subclassing, that's what, using inheritance. But what, where we will end up with, okay, we end up with the subclasses means implementing complex networks of multiple inheritance, which is memory inefficient, and at a certain point it is just cannot be scaled. Okay, so I think we would have seen this multiple times, right? We create a hierarchy of classes, we keep on inheriting from the base class, we provide additional functionality, but we end up with lot of subclasses. Okay, and sometime it becomes very difficult to scale. Okay, that's what we are explaining here. So likewise, attempting to implement the same functionality with the properties bloats each instance of the object. Okay, same thing we can achieve by implementing a lot of properties on the instance. Okay, again, the problem with this is if some of the functionality don't want, if some functionality or some feature don't want all the properties, right? So some of the properties will become unused. Okay, simply they are unnecessary properties which your object has to deal with. That's why they say Likewise, attempting to implement the same functionality with the properties bloats each instance of the object with unnecessary properties, which is a waste basically. For the above reasons, decorators are often considered a memory efficient alternative to subclassing. Okay, decorators can also be used to specialize objects which are not subclassable. See, understand this point. Some sealed classes basically. Okay, in C sharp or in Java. In Java, it's called final classes. Okay, so decorators can also be used to specialize objects which are not subclassable because they are sealed completely, whose characteristics need to be altered at runtime. Okay, or generally objects that are lacking in some needed functionality. Usage in enhancing APIs. The decorator pattern also can augment the facade pattern. A facade is designed to simplify interface with the complex system it encapsulates. Okay, so basically, facade pattern provides a simple interface to hide the complex system underneath, but it does not add any additional functionality to the system. Okay, however, the wrapping of a complex system provides a space that may be used to introduce new functionality based on the coordination of subcomponents in the system if we use the decorator pattern. For example, a facade pattern may unify many different languages dictionaries under one multi-language dictionary. Just take an example, okay? A facade pattern may unify many different languages dictionary under one multi-language dictionary interface. Okay, the new interface may also have new functions for translating words between the languages. Okay, this is a hybrid pattern. The unified interface provides a space for augmentation. Think of decorators as not being limited to wrapping individual objects, but capable of wrapping clusters of objects in this hybrid approach as well. Okay, with the use of decorator pattern, not only I am basically augmenting all my different languages dictionaries, but apart from that, I'm also providing a functionality of translating words from one dictionary to another dictionary if I use decorator pattern. Okay. So UML class and sequence diagram. Okay, I'm going to explain in detail. So let's go to the steps to implement decorator pattern. Okay, the first step, subclass the original component class into a decorator class. Okay, first what we have to do is we have to subclass the original component class into a decorator class. Okay, so if you see here, this is my component. It's an existing component which is lacking some features or needed functionality. So what I will do, I basically create a subclass called decorator from that component class. That is the first step. In the decorator class, add a component pointer as a field. In this decorator class, basically I maintain a reference to this component. Okay, and third step, in the decorator class, pass a component to the decorator constructor to initialize the component pointer. Yes, this decorator will receive a reference, okay, a pointer of your component, and when this decorator's constructor is called, we are basically initializing the composition of a component or the aggregate property inside this decorator, which is basically pointing to component, okay, that will be assigned with the component object. Okay, now, in the decorator class, forward all components methods to the component pointer. See, so whenever I call the method operation on my decorator, right, what I'm doing, I'm simply calling component dot operation. That's it. Simply I'm forwarding the request to the component. Okay, so this is a abstract base class. Don't get confused on what additional features we are adding. No, this is just a abstract base class. Now we have to provide the concrete decorators basically. So in the concrete decorators, which basically inherit from this base class, abstract base class decorator, what they will do, okay, they are going to call your operation. So first they will create your component, because without your component, how will you add additional behaviors? The first thing these concrete decorators have to do is first call the component dot operation by calling the operation method, then you add your additional behaviors, okay, to that created component. So let's take an example of a circle. Okay, my component class, which is a legacy class, which only draws a circle. Okay, which only draws a circle. Now what I want to provide a decorator which basically draws a thick border around it. Okay, and also I want to fill some color into the circle. So filling the thick border is done by this decorator one, and filling the circle with color is done by decorator two. Just for example, I'm explaining. Okay, so what I will do is the first thing, operation. So the operation is draw circle. So first what I will do is first I will call the operation which will internally call the components operation, that is a component dot operation. Okay, so first I will draw the circle, then I will apply the thick border by adding an additional behavior. Again, in the second decorator, again I will call the operation which will basically draw the circle, and then I will fill the color into the circle. I hope you people understood the mechanism of this pattern now. Okay, so again this component is a interface, basically a contract, so you should have its concrete clause also. Okay, like a circle class, this is I shape and this is circle, which is basically implementing the contract I shape, which has an operation called draw. Okay, so that's it. I think you people are understood how the things work now here. So what are the pros basically? Now, the decorator pattern can be used to make it possible to extend the functionality of a certain object at runtime. Yes, we can do that. Okay, so this is really useful when you have some DLLs for which you are missing source code itself. You don't have source code itself, so you have just the DLL file. So what you can do, you just load the assembly at the runtime, you create object of that particular library and you enhance it. The decorator pattern is an alternative to subclassing. Yes, subclassing adds behavior at compile time and the change affects all instances of the original class. Yes, but a decorator can provide a new behavior at runtime for individual objects to which you want to decorate basically. Okay, so subclassing is basically compile time, and yeah, the decorator pattern is basically runtime behavior addition. Decorator offers a pay as you go approach to adding responsibilities. Instead of trying to support all foreseeable features in a complex customizable class, you can define a simple class and add functionalities incrementally with decorator objects. Yes, I agree with that. Cons. Decorators can complicate the process of instantiating the components because you not only have to instantiate the component but wrap it in a number of decorators. Yes, yes. So here the instantiation process will become very complicated. I will explain this with a demo. I have a example code written for it. So apart from initializing your component in its constructor, you have to take a additional responsibility of initializing all your decorator classes also. Always remember this. Okay, so it's a chain, a initialization chain, I can say. Okay, then it can be complicated to have decorators keep track of other decorators because to look back into multiple layers of the decorator chain starts to push the decorator pattern beyond its true intent. Okay, so it will become complicated to have decorators keep track of each other decorators because what happens is when you have a lot of decorators, it is very difficult to track all these things because you have to track the entire chain which you are using to keep on adding various new functionalities to your runtime object. Okay, so that are some cons associated with the decorator pattern. So let me explain now with a demo. Let me show a demo for this. Well, yeah, let's take an example. I have a legacy component called iBike. Okay, in my case, I call it bike basically. So for a bare minimum bike, okay, which I receive from the showroom, okay, so I need to add some decorators. I need to add some accessories to my bike, okay, and the bike can be electric bike or it can be a petrol bike. Okay, both the combinations I have considered. Just a trivial example. Okay, so my bare minimum contract, which is called iBike, the iBike interface says that it has two methods: get details and the get price. Okay, so let's have a look at my concrete bike now. So this iBike is equivalent to my UML diagrams component over here, which has some operations. Okay, so my iBike is basically a component over here. Then I will provide a concrete implementation for that component. So electric bike, which implements iBike, and yeah, the price is 1 lakh rupees. And yes, details is it's a electric bike. Okay, again, a petrol bike price is 70,000, and yes, it is just a petrol bike. Okay, or you can give other details like how many wheels, what is the engine type, all other details you can give, but just for the demonstration purpose I'm using a trivial example. Okay, so these two concrete classes are belonging to this part of your UML, the concrete implementation of your component. Okay, so this is iBike and this is petrol bike and electric bike. Now let's move on. Yeah, The bike accessories decorator base, the most important thing, my decorator pattern, which is abstract base class, okay, which implements the interface iBike. Okay, so this thing over here is basically the decorator over here. Okay, abstract base class, a kind of contract you can say. Okay, uh, so if you see here, this particular decorator's constructor receives my component, that is iBike. Okay, no specific, not concrete bike. Okay, it should work for any kind of bikes which basically implement the interface iBike. Okay, so that's why I'm passing a iBike pointer. Okay, and this iBike reference will be set to my iBike reference variable of my decorator class. Okay, so whatever bike I'm passing here, that will be kept inside this decorator. We will assign it, and then what we do, get price basically returns the bike dot price by underscore bike dot get price details, and get details basically returns the underscore bike dot get details. Okay, so this is the bare minimum setup, okay, for my decorator. Okay, the abstract base class, a contract for my decorator. Now I will provide the concrete implementation to my decorator by overriding these methods. Okay, see, this is the base thing. Okay, these are the base features provided by my bike: get a price and get details. Okay, now I will start adding accessories. So first thing, bike accessories decorator base is being inherited by my security package decorator. So I want to add a security package accessory where I will put some smart keys basically. Okay, some smart devices and some smart keys, which is basically a keypad kind of, where you can enter some password to unlock your bike. Okay, so that kind of accessory is available in market. So what I did, I basically created a decorator for security package decorator. Okay, again, see the constructor guys, very simple. I'm receiving a bike instance and I'm passing that bike instance to my base class. See the chaining here. So what happens, I'm basically setting my bike pointer, which I had explained earlier, to the supplied bike. Okay, then after that, what I'm doing, I'm overriding the virtual methods provided in my base abstract base class, which is called my decorator. Okay, the bike accessories decorator. Okay, so I'm going to override these base class implementation or the base class methods. So what I will do, look at the beauty of this pattern. Public override string get details, first call base dot get details. So whatever bare minimum things which are coming with my bike, right? Okay, first I will print all those details over here. So base dot get details basically calls your underscore bike dot get details, whatever bike you are passing, though whatever bare minimum things are coming with the bike, those will be printed, plus you add a security package. Okay, same way, price wise, the moment I add new accessories, obviously my price will increase. So base dot get price, whatever base price I have for my bike, plus I will add 5,000 for security package decorator. Okay. Again, for the sports package decorator, I will inherit from bike accessories decorator base. I will pass my desired bike as a pointer, sorry, as a instance to this constructor, and it will be set to my decorator base classes pointer, the bike pointer basically. Then what I'm doing over here, again, get details, first get the bare minimum details of my bike, plus you add, yes, sports package has been added. Now I want a sporty look for my bike, so I have opted for a sports package. And then again, price will also increase, get the base price plus add the 7,000 rupees extra for getting the sports package accessories. Okay, so when it comes to executing, when it comes to implementing these decorator pattern, my client is my main program. See, for the electric bike, first example, for the electric bike, okay, I will create an instance of an electric bike from the concrete class. Okay, then what is the base cost? I just call electric bike dot get price, it will print a base price. Now what I will do, what I'm going to do is I will use my base class reference variable of my accessories decorator base, the bike accessories decorator base, which is this one. Okay, this is my abstract base class. I will make use of its reference variable here. Okay, bike with a security system equal to new security package decorator, and I will pass my bare minimum electric bike. Okay, that's it. So this particular decorator will add the security package to that, as already explained. So price after accessories decoration. Now when I print bike with the security systems dot get details, you will see the result: base price plus the extra cost and also the bike details. Same for the petrol bike. Okay, what I'm doing, I'm printing the base price of the petrol bike, then I'm adding the sports package to my petrol bike. Okay, again using the base accessories decorator base class reference variable. Okay, so I will print the values after adding these accessories, what will be the details and what are the prices. And third scenario where I'm adding both security as well as both sports package, sports accessories to my petrol bike. Okay, so in this scenario, see what's happening. First, I will print what is the base price of a petrol bike. Then I will add a security package. Okay, then I will get that bike with the security accessories. Okay, after adding the security package decorator, what I will do, I will take that object reference bike with security accessories, I will pass it to again sports package decorator. So first I added security package, now I will add sports package, and I will call using this object, I will get the details, and I will see that my petrol bike with the base price will be added extra 12,000 because of security package and sports package, and it will print the overall cost. Let me run the program. So as you can see, electric bike base cost is 1 lakh rupees. Okay. Price after accessories decoration. See, bike, electric bike plus security package I had added. So cost become 1 lakh 5,000 rupees because for electric bike, the security package costs 5,000 rupees. Again, for the petrol bike, base cost is 70,000. Okay. Price after accessories decoration 77,000 because for sports package, the cost is 7,000. Okay. That's why it's printing 77,000 and it is showing you that these things are added now. Okay, and then price for accessory, the third scenario. Okay, where I add both the accessories, security as well as sports. See, petrol bike plus security package plus sports package cost become 82,000. That is 70,000 is the base price of my petrol bike. Okay, I added the security package of 5,000 plus I added a security, sorry, sports package of 7,000. That is 7 plus 5, 12. So 70 plus 12,000, that's overall 82,000. Okay. So this is a example. I think with this you people would have understood the mechanism of decorator pattern. Okay. I hope you people will apply this in your day-to-day design activities. Thank you for listening and have a nice day, guys.